Hey there, today I am going to discuss about analysis and design of industrial building. This is my college 4th year final project, and it goes like this. The brief contents of the topics are introduction, description of structure, loads, codes, analysis, design of slabs, foundation design, connections design, making of designs, results, and references, and conclusion. Then the brief introduction which I am going to deal is our project mainly deals with the analysis and design of our main industrial structure. That is done by the software system called StatPro, and some of the foundation is made by Stats Foundation. Some of the unique challenges in our project are long spans, dynamic loads, large steel truss, heavy wind loads.
Coming to the types of buildings, types of industrial buildings, steel frame buildings, these are commonly classified based on the usage of them, and these are classified into three broad categories: the warehouse and factory buildings, large span storage buildings, heavy industrial process plant structures. Warehouse and factory buildings are used for small scale, and the storage buildings are for medium scale. Industrial building done in Google SketchUp. So you can see the long span and the heavy storage of the building. Next, the task involved in the design of industrial building. So they have two special systems to be fitted for the ventilation of the building, and the internal wind loads on the roofs are also very high. So we have to tackle with them, and it also involves the design of both welding as well as truss bolt connections, and the design of foundation for the dynamic loads has to be done. This slide shows you the type of roof we have used in the industrial structure. It is an arch roof. The asbestos sheets are laid on the purlins of the truss, which in turn places the loads on the columns, and which it is in turn transferred to the foundations. Coming to the description of structure, as I told you, it is an arch roof truss. Purlins are laid over this truss, and asbestos sheets are used as a roofing material. Columns are made by RCC, which is reinforced concrete material. And this slide shows you the building structure.
The total width of the truss is 5 meters. The cross section contains of two triangular elements with a base width of 2.5 meters. In the longitudinal directions, these triangular elements are placed in parabolic manner to obtain a complete truss of required length. This is the brief layout of the truss element, which is designed in AutoCAD, which is to be imported into STAAD. It is also shown in Google SketchUp. Coming to the arrangement of truss, our structure consists of 8 bays with spacing of 10 meters between each bay. Purlins are perpendicular to the truss direction. Purlins are given a spacing of 2.5 meters between the purlins, which are perpendicular to the truss direction, which is represented in the diagram. This diagram consists of trusses, a series of trusses with a spacings between them. Even the columns are given some spacing between them, which is represented in the diagram. In this diagram, we can see that purlins are laid over the trusses in perpendicular direction, and then asbestos roof sheeting is made over the purlins. Coming to the columns which we used in the design, these columns are attached to the truss by using nut bolt system. The density of concrete used is 25 kilonewton per meters cube. The size of the column is 0.4 meter by 0.65 meter, which is rectangular in section.
Coming to the loads falling on the structure, there are 4 types of loads. There are dead loads, post loads or lie loads, wind loads, and earthquake or seismic loads. Structures carry different types of loads, and the structural element has to be designed for all the loads that are likely to come on the structure in its entire lifespan. Coming to the dead load, it is a permanent load on the structure, and it includes weight of all elements. Coming to our structure, these elements are truss members, purlins, and the asbestos roof sheetings. And the imposed loads or live loads on floor shall comprise of all loads other than dead loads. And we have taken the dead live loads on this structure as 0.2 kN per meter. This is applied over the length of purlin. Coming to wind loads. Wind load is one of the most important load, but most difficult to calculate. This depends on terrain, height, shape of the structure. The wind pressure is a function of wind velocity and shape of structure. The wind loads are calculated by the formula Z equal to K1 into K2 into K3. The K1, K2, K3 are the factors where K1 is the risk factor and K2 is the terrain, height and structure factor and K3 is the topography factor. Here the VB is the basic wind speed and from there we get VZ the design wind speed. And the K1, K2, K3 factors have to be taken from the code IS 875. The earthquake loads are very important for the structures. These seismic loads on structure shall be in accordance with the code IS 893. The StatPro does the design calculations for seismic loads also. Now coming to the load combinations, a careful combination of various loads has to be considered. The structure has to be analyzed for combination of loads. Some of the load combinations can also be excluded, such as wind load and seismic load cannot come at the same time. Slide shows the codes. In StatPro, the scene analysis is done and the code has to be given as IS 800 limited design and the commands to be used steel design and member takeoff. The required parameters are then assigned to the steelers. Coming to the RCC analysis, it is done using the code IS 456 and the commands to be given are design of the column and design of the wall and the takeoff. And the procedure for analysis, first the structure is transferred from AutoCAD. It is analyzed for earthquake loads with a factor of safety of 2 and once all the members are stable, it has been then analyzed for dead loads. Then for live loads and then for the combinations. This slide shows you the photo of the StatPro and there you can see the loads defined for this structure and the structure is analyzed for these above loads. After the analysis is complete, we get the cross sections and specifications of all truss members and purlins. The reinforcement design details for RCC columns and their arrangement can also be got. And at last the steel takeoff and concrete takeoff for the whole structure can be obtained.
Design of slabs. There are two types of slabs, that is one-way and two-way slabs. Criteria for slabs is LY by LX is greater than 2, then it is one-way slab. If it is less than 2, then it is two-way slab. In this project, the slabs are all one-way. The size of each slab is 50 into 5 meters. Design of footing. The footing is of isolated type. It is designed to carry loads from roof as well as imposed loads inside the building. It is assumed that load on the floor as the plinth as 5 kN per meter. A sample of footing and plan elevation is here. Here are some of the references. Structural analysis by Ramamrutam, structural analysis by R.S. Kurmi, design of RCC structures by B.C. Punmiya, design of RCC by Ramamrutam, a teaching guide for steel connections by Perry S. Green, design of steel. Conclusion is the design of all structural members were made using definite sections like pipe for all trusses, I sections for purlins, etc. and all the members passed the section. Design of foundation is done separately by isolated footing type. Thank you.